guess we're recording now, so I'll go ahead. Hey everyone, I'm Oren, the product manager for Gnostos's conditional tokens framework. And today we're going to go through a quick primer on the conditional tokens framework, how it works, and kind of some of the things that it's useful for. We'll dive down to actually deploying some contracts and playing with them, just so you can get a good feel for how they work at a reasonably low level. I'll go ahead and share my screen to start with, and we can just jump into some slides. So the conditional tokens framework essentially enables tokenized logic. So if this, then that, where the value of a token depends on the outcome of some event as reported by an oracle. These tokens can then be combined to form tokens whose value is contingent on kind of arbitrarily complex logic. So if A and B or C, then it's worth something, otherwise it's worth nothing. One obvious use case for conditional tokens is prediction markets. That's kind of what they were built for, and it's enabled the DXDAO to go and build Omen. But as a primitive, conditional tokens enable so much more. A quick TLDR on how they work. Essentially, you create a condition and then you deposit some collateral. And the conditional tokens framework spits out a conditional token that corresponds to each one of the outcomes or collections of outcomes for that condition. At some future date, an oracle resolves the condition, and then anyone that's holding the corresponding conditional token can redeem it for the underlying collateral. You can then go and combine these conditions to build more complex logic. So conditions that result in positions dependent on the outcome of more than one condition. This is a really unique feature to the conditional tokens framework, and it's one place where things get really interesting. This allows things like trustless milestone-based payments, where milestone 2 can only be paid out if milestone 1 has been completed. Crowdfunding, where the project only receives the funds if more than X amount of funds are raised by more than Y amount of people. And then futarchy, where governance decisions are made based on their predicted impact on some future events. The other place where, the other piece of the puzzle that really adds flavor is the oracle. The conditional tokens framework is oracle agnostic. Any address that can interact with the conditional tokens contracts and with the contracts interface can act as the oracle. And it's that oracle that decides when, how, and why a condition is resolved. In some cases, it may make sense for a trusted individual or a trusted multi-sig to be the oracle, so they can kind of have a human touch on that resolution. In other cases, you may want to implement some kind of logic around the resolution, in which case you'd write a contract to implement that logic or use an existing contract with some specific logic as your oracle. And so in that case, you may be able to take, say, some on-chain source of truth, the price of an asset or assets having moved to or from another address or anything else that can kind of be represented on chain could then be kind of codified to be part of the logic for the resolution of an outcome. I'll just skip through to this next slide. Essentially, this is your opportunity to learn about and build on the conditional tokens framework. There's a couple of links here. If you get stuck or you want to dive in more, come join us in the chat. If you want to dive into our documentation and start building, then there's a link there to our docs website. And with that, I'm going to switch modes here, and we'll dive into the tutorial that we actually have up on the doc site. We're going to run through that quickly today. And so that will be mostly over in Remix. So I'm going to go ahead and share my screen again. So here we are in Remix. Essentially what I've done is grabbed our conditional tokens tutorial here. There's a link to a GitHub gist, and you'll go and import this gist into Remix. From the home here, you'll just hit the gist button, drop in the link to your gist, and it will load up these 3 Solidity contracts. They should all compile without any issues. And then you're going to jump over to deploy and run transactions. And I'm just going to run them in the JavaScript VM here. If you want, you can use your Web3 provider and put them on a testnet or on mainnet if you're really game. All the contracts are fine. They're fine to run on mainnet, but it's obviously costly. So we'll keep it in the JavaScript VM for today. So what we'll do first is just again following along with the tutorial here, we'll deploy our tutorial contract. Jump down here and we'll just go to our, hold on, let's just double check and see which one we're supposed to be deploying again. Tutorial.sol. Should give us this toy token contract. Here we go. So we need a name. We're just going to call this one token A, and we'll put this on a symbol A. And we'll deploy another one, token B, and we'll give this one symbol token B. I'm actually going to increase the zoom on this a little bit. I think that might make it better for the recording. So now we have 2 toy tokens down here. Then we're going to deploy the conditional tokens contract. So we'll jump in here and deploy our conditional tokens contract. Let's try that again. Bear with me. Out of gas. Aha. So let's bump the gas limit up. Go to 8 million. Why not? There we go. So that needed a little bit more gas than what was being provided by default. So now we have an instance of the conditional tokens contract, and this is where we'll spend most of our time today. We'll jump over to the next section in our tutorial here, and we're going to first learn a little bit about conditions and setting them up. So the first thing we need is an oracle. We're going to use our own address as our oracle for the duration of this, and so just the first address that was generated by the JavaScript VM here. And I guess we'll start by actually creating a condition. So we'll go down here to got it. We'll go to get condition ID, which is right here, and we're going to drop in our own address as our oracle. Question ID, we'll just use a blank or a mostly blank string of bytes, ending in a 1 here. And for outcome slots, I think for this first one, we'll do 3 outcome slots. I believe that's what we wanted for the, yep, 3 outcome slots. And we'll call this function. And so this is going to tell us now what our condition ID is in the scenario where we've got our own address as an oracle, and we've got the question ID set to 1. So this is our first condition. I'll save it like this, and we'll save the condition ID for future reference. And then from here, we're going to go and prepare a condition. So we're going to go to the prepare condition function up here. We'll drop in the same details that we had in get condition ID. So the oracle, the question ID, and the outcome slots 3. We'll hit transact, and this is going to prepare our condition on chain. So now we have an instance of this condition live here in our instance of the conditional tokens contract. From there, we can now do things like splitting collateral out into positions and then start transacting or transferring those conditional tokens around. One thing that's really important for us to get a handle of first is just bit arrays and how they're used in the conditional tokens contract. So Alan, when he first did this tutorial, had a really neat little trick here where he opened up the JavaScript console to teach a little bit about how bit arrays kind of work. So essentially, we store, when we're trying to call the split position here, we'll have or actually several of the functions when we're calling them. You'll need to put in this index set variable, and it is a unsigned integer, but the unsigned integer essentially represents a bit array. So what we're doing here is, say we've got 3 outcome slots. We're representing them as a binary number. We can do it over here and remix, I guess. So if we've got, say, 3 outcomes, A, B, and C, then we're representing those as binary numbers. So we'll say a condition where, I guess we'll go back and say when just A is true would be a binary number 001, and the integer representation of that would be 1. In a case where we had just B, we would have 0, 1, 0, and the integer representation of that would be 2. In the case where we had just C, then the integer representation, or the binary representation is 100, and the decimal integer representation is 6, I believe. Let's just make sure of that. So the trick that Alan teaches us in this tutorial is to throw these in as a binary number here. So 0B, and we'll go 1, 0, 0, and that should give us 4. So my math was off. That's 4. That makes more sense. And now say we wanted to do a position that was, say, A or B, then we can toggle multiple of these to 1. So we can say A or B, but not C. So the binary representation for this one here is 0, 1, 1, and the integer representation for 0, 1, 1 is 3. So anyway, that's kind of a quick primer there on how we're using these kind of bit arrays. And we'll jump through to the next section here. There's a nice little cheat sheet here on the developer docs. So we'll go ahead and set up a basic collection outcome now. What we're going to do is take our, we're going to use, because we're splitting from collateral, we'll use just a blank array, or just 0 as our bytes 32, and we're going to jump down to where are we at? Prepare condition here. Sorry, no, we already did that. We're going to get. Hey, Alan, what's up, man?
Hey, sorry about had some trouble this morning with some stuff. Also,
Not a problem.
just found the link, so my bad.
No worries. We're just jumping in, so you can help me through my fumbling. It's just us where we're just recording, and we're going to throw it up on YouTube later.
Okay, cool. But yeah, it's Git collection ID. The 0 bytes 32 means that it's a root collection, so it's kind of a collection with no outcomes.
Right. So yeah, we'll drop in the zeros for our condition ID. We'll use the condition ID that we got earlier. And then for an index set, we can pick any one of the outcomes or collections of outcomes here that we created earlier. So we'll just take, to start with, just option A. So we can just drop in the integer representation of that as 1. We hit call, and we get this bytes 32 representation of our collection ID. So this is condition 1 in condition ID 1 in the case of A. So collection ID, I forget how you wrote this one, Alan, in your tutorial, but never mind. So we'll just say, I don't know, what, or outcome A. Oh, I don't remember now. It's just like this, isn't it? Yeah. Cool. And then we can do the same thing here if you want to say B. There we go. We'll drop this in, make this 2, hit call, and we get a new outcome, or a new, collection ID. And say we want to do A or B. I guess we should get one for C as well, just to be thorough. So we get C, and then last one, we go A or B. I'll drop that in here. So now we've got all of our, oh, I guess I need, can I just do this in Remix? Nope. So now we'll jump over to our next section, positions here, and we're going to grab the position IDs based on these outcomes with a specific collateral. So again, we can use this getter function, get position ID, and we can grab our collateral token, which is one of the tokens that we deployed earlier. Jump up here and grab a toy token, so we'll copy the address of that, drop it into the collateral token, and we'll grab the collection ID for one of our tokens here. Hit call, and now we get the position ID, and this is actually the ERC 1155 token ID for this conditional token. So I'll say A, so this is saying token A, condition A, and drop in our ID. And then we'll do the same thing, A for B, and we'll do A for C, and A for A or B. Quickly just drop in each of these with without the magic of post-production editing, there's going to be a couple of short dead periods here.
Yeah, there was a lot of, when I was recording the video, there was a lot of pauses where I just sat there for the longest time without like saying anything because I was just sure what to say. The original video is actually really choppy, but it's fine, I think.
So we'll change out our token and we'll just generate the same positions for the position IDs for our other collateral token. Your audio is kind of quiet today, Alan.
Is this any better?
That is a little louder, I think. Or maybe I'm just listening harder.
Actually, I've been kind of
there we go.
Messing with some settings. Okay, yeah.
Yeah, that got much louder. Cool. So we've got one condition and two tokens. And we've got the condition IDs for various different outcomes or outcome collections, and then we've got the token IDs for the collateralized versions of those outcomes, or for the actual conditional tokens. So now we can move on to splitting from collateral. So now we need to jump up here and mint some of our toy tokens. So we'll mint them to our own account. And let's mint 1,000 of them. Why not? So we should now have a balance of 1,000. We can check that by dropping our balance in here, or our address in here. Great. And we'll do the same for token B. We'll mint them. 1,000. And check out balance. And we're good to go there as well. And the other thing that we'll need to do is quickly approve our conditional tokens contract. So grab this address. Why is it not letting me copy it? That's odd. There we go. Cool. So we'll approve this address to spend all 1,000 of our tokens. There we go. I'll do the same for my other token. Perfect. And now we're good to go to start splitting from collateral. So we'll jump back into the conditional tokens contract here. And we'll say split position. We'll jump over to the split position function. So here we need most of these variables that we came up with earlier. So our collateral token we can grab the address from up here. We'll go token A. And I guess I should just drop these in here for continuity's sake. Token A and token B for easy access. There we go. So we go to split condition. We'll drop in our collateral token, token A. This is obviously any ERC20 token, or most. I'm sure there's some that are broken because the token themselves are broken, but we'll say any for the time being. Parent collection ID, we're splitting from collateral. So again, we can use empty bytes or just 0. And we're going to grab our condition ID from earlier. And our partition here is essentially an array of the, what do we call these again? The index sets. And these need to be mutually exclusive, if I recall correctly. So we could have an index set that is, say, 1, 2, and 4, because those would be mutually exclusive. Or we could have an index set of 3 and 4, because those would be mutually exclusive, but we could not have, say, an index set of 1, 2, 3, and 4. So in this case, we'll try 1, 2, and 4. And we'll split 100 of them. So we'll call transact here, and there we go. It should have split. And so what we can do now to verify that this actually happened as intended, and maybe it's good practice to do this beforehand, is double check our balances. So they should have been 0. And now we should be able to go through here and check that they're actually, there should be 100 of each of these tokens in our account. We can do we'll just do them individually. You can do them as a batch, so you can get this in one call, but that might be a bit hard to read on screen here. So I'm going to drop it in. We'll look at our address for our conditional token, and then we're going to grab our address for this account, and it should return 100. And we can double check that for each of our tokens that we've just generated. So we've got 100 in that one, we've got 100 in this one, presumably, and then this last one here should be a balance of 0 because we did not split into this index set, into this collection. So that all kind of worked as expected. Let's go ahead and do the same thing for token B. There we go. And I'm not going to bother checking the balances on those because it should have all worked as expected. Alrighty, now we'll go ahead and try splitting from another condition, or splitting from unions, as opposed to from collateral. And so in this case here, what we're going to do is grab a parent collection ID rather than having some blank bytes here. We'll go ahead and grab our collection ID from one of these previous collections. And so actually, Alan, do we need to set up another condition for this? Or can we, I guess, yeah, maybe doesn't make sense to split from the same condition.
I mean, you can split from the same condition, actually. So, I mean, I don't know if it practically serves any purpose, but you can do it.
Yeah, well, let's set up another condition just so that we're doing things a bit more like you would actually do it in the real world. So I'll jump in here and prepare a new condition. We'll make the condition ID 2 this time. And we'll just go 2 outcomes for this one. I'll stay as the oracle. And I'm going to just calculate the other stuff that we need on the fly as we need it, rather than going through and documenting it all to start with. So I'll grab the condition ID for this. And here we'll column high and low. I said low. Cool. I don't think we need to go through all that actually. We should be able to use the same chart there. All right, cool. So splitting from a union, then we'll use, I guess we need to get our condition IDs, our collection IDs for this hub. So let's go ahead and do that then. Collection IDs, we'll grab, we don't need a parent collection ID for this yet. We need a new condition ID, which is this one. And we need an index set of 1 to start with. And this is going to be high and low. And now we're going to go and split our position up top using the parent collection ID, I guess, of high.
Wait, did you already split with that condition?
I did not actually.
Yeah, so like you would still use the root collection ID because like you still have stuff at the root. And or are you trying to do a deeper split?
Yeah, so we want to do a deeper split now. We already did one where we already did one from root, like from collateral. So now we
okay. So you actually have, in that case, which you would be splitting from A, B, or C, and then you would split from that to A and high and B and high or something, or A and high and A and low or something like that.
Right. So in that case, we use our condition ID here, and we'll use the collection ID for, say, A. What's this?
Wait, no, that's it. Yeah.
And our partition would just be 1 and 2. That looks like it makes sense. If we want to do, say, 20 of these, and we should figure out the position IDs for these. So it'd be A and high. guess we need a collection ID for A and high. So we'll get our parent collection is this. We need a collection ID, which is this. And index sets, so one to start with. A and low. And from there, we can get our position IDs. Assuming that we used D8, right token there. Cool. And so now we should be able to call balance of, and we should have 20, cool, of B and low, and 20 of B and high. Second address here. Cool. So we successfully split from collateral and then also split from another condition. And so I mentioned kind of earlier in the intro that this is where I think things get really interesting, is splitting from splitting into kind of deeper positions, so you can create this kind of more complex logic around when or how a condition resolves. So in this case, we have a position that is true if both A and high are true, and a position that's true if both A and low are true. So we basically created these two positions here. Or actually, sorry, it was B and high and B and low. Cool. So we can go ahead and move on to combining outcome collections. Or actually, is that what we just did? Yeah, I guess we did. We just kind of skipped ahead. Cool. So we now have our
Oh, I realized I was muted. Sorry. I wanted to say that you did use A and high and A and low, but like the token was token B, I think.
Oh, right. Yeah, it was too.
Anyway, yeah.
Yeah. Cool. And so now we can we've split into these deeper positions, so we kind of skip through a few of these steps here, and we can try merging some tokens back together. And just kind of as a high level overview there, what we've done is split our collateral into multiple outcome tokens. Each one is kind of mutually exclusive. If we have a full set of those outcome tokens, we can merge them back together to reclaim that collateral prior to the condition resolving. So in our case here, we can combine kind of A, B, and C to give us back token A or token B. So we'll jump in and try merging some tokens back together. What we should do quickly is just check our balance. So let's say this token A in the condition A. We'll go balance up again. So our account here, and we'll drop in our balance. We've got 100 of these tokens. So we'll go ahead and try to merge back, say, 50 of them. So we'll jump up here to the merge position function. We need our collateral token address. We're working with token A. Our parent collection ID. So in this case, we're merging from collateral, merging back to collateral from a first level condition there. So our parent collection ID can just be zeros. Our condition ID is condition 1's ID here. And our partition is 1, 2, and 3. Right, no, sorry, 1, 2, and 4. And we wanted to try to merge back 50 of them. And before we do that, we should just double check what our balance of token A is. So we'll jump up here to token A, and we'll do balance of. We should see 900. And after our merge here, assuming this goes through, we should see our balance here in our toy token change to 950. Great. So that was us merging from a position in these 3 tokens, holding 50 of each, merging them back to 50 of our collateral tokens. We'll skip on here to merging, well, I guess, should we try merging a deeper position? Alan, do you think we get benefit out of doing that as well? I think you're muted, Alan.
If you'd like, though, honestly, like all this, any split you can do, essentially, if you undo that split, you get a merge.
Right.
So, like, I mean,
yeah,
I mean, okay. That's how I originally presented it. If you want, you could do another merge, but I don't know.
That's all good. I don't think we need to, and we're starting to run low on time, so maybe we quickly touch on transferring. I mean, this is a pretty easy contract call, so it's not a huge amount that we need to worry about here, but I'll grab another address here, copy it, and then we can transfer a few tokens. So you've got 2 functions here, safe transfer and safe batch transfer. The thing that's worth talking about quickly, the tutorial here breaks up into 2 sections, is just that there's a difference between transferring to an EOA account, so like someone's address that's derived from a private key, versus transferring to a contract account. The contract account has to implement what is it, the ERC1155 receiver function. And if it does not, then the transaction will fail. So you can't send ERC1155 tokens to any address. It's either to EOA accounts or to contracts that implement the function correctly.
Yeah.
And so here we're just going to send it to another EOA account, and kind of skip over the ERC1155 receiver to other contracts. But the tutorial there kind of explains that in more depth. So we're going to go to our other address. We're going to go from our address. You do put in an address, even if it is your own address. And again, like ERC20s, you can approve other addresses to send your tokens. We'll try sending one of these that we have a position in, and we'll send 10 tokens. But here, I made this mistake one time. It should just be empty. So 0x, I think at one point I put 0x0 and couldn't figure out why it was failing. So it's an easy mistake to make, or at least it was easy for me. But we just want to drop in empty bytes there. Before we go ahead with it, let's just check the balance for this account. We'll grab the ID here and the account that we're sending to, make sure that it has a balance of 0. You can see a balance of 0 there. We'll send it 10 of these tokens. And now if we call this again, we should see a balance of 10. So now, I guess we'll skip over to reporting. I think this is kind of one of the more fun parts. We'll go ahead and try reporting on one of these conditions. So we're going to call, just minimize a few of these. We're going to call report payouts. We'll grab the question ID. So not the condition ID, but actually the question ID that it was derived from. And so what this does here is actually report for any of these conditions that have been created from this same question ID. So if you have conditions using the same question, but say with different oracles, or I guess they can't have different oracles, sorry, if they're derived from different tokens, or have different outcome sets, I guess, then this resolves for all of them. Here we'll do the payout vector, and I actually need to go and refresh on how this one works. So Alan, can you remind me?
Yeah, so you send in an array with the same number of elements as the number of outcome slots. So like in the case of the first condition, it would have 3 outcome slots that correspond to the 3 tokens that you've labeled A, B, and C. So you pass in an array of numbers, and the payout associated with a particular outcome slot corresponds to how much proportionally that value takes from like the whole array. So it's kind of hard to parse.
So it's like it's a ratio. So like you have here I wrote kind of 1, 0, 0. So this would be outcome 1 gets 100% of it. But if I was to change this to like 1, 1, 0, then it means outcome A and B get 50. Split it 50-50, right?
Yes.
And then these numbers here could be any number I want. So if I wanted a 50-50 split, I could still do 5 and 5, or 10 and 10, or 100 and 100, as long as they're even. Or then alternatively, like if we want some other ratio, we can set these numbers differently. And the contract will just figure out the kind of ratio to pay them out based on those numbers.
Yeah.
Which is a really elegant solution for it. So we're going to go ahead and report the payout here. 730, which is a fun payout vector. And from here, then we can jump over to redeeming. So we should still have a balance of condition A in the case of, or token A in the case of condition A. We'll just check that balance quickly. I haven't been keeping exact track of what it is, but just so we can see this. I grabbed the token address, not my address. warning, don't ever send tokens to their contract address. All right, so we've got 50 of these tokens, and now we'll go for we'll try to redeem those at that position. So we'll jump up here to redeem positions. We need our collateral token address, our parent collection ID, which is again just 0 for this one because it's the root condition. And we'll go to condition ID. Grab this here and the index sets. So here, do I drop in all of the index sets that I am trying to redeem, or just, I guess, does it make a difference if I just drop in 1, or should I be dropping in like 1, 2, and 4?
I would drop in all of the index sets for which you have value for.
Right.
The reason why is even though like you're only going to clear out even though you're only going to get value out of one of the, or I guess you would get value out of both A and B, but
not out of C.
But like, say if you have C, even though you don't like get anything out of dropping C in, you're actually clearing the storage of C, so it might save you on gas. So it's worth dropping in everything you have value for, because chances are, like, by that time you can't really get value out of C unless you do some stuff and somebody has a really good deal out there for you, basically.
Yeah. So while you were chatting there, I checked the balances. We had 50 of A, 50 of B, 50 of A, 40 of B, and 50 of C. So we should see kind of 70% of 50. No, it's not 70. Oh, yeah, I guess.
Yeah.
70% of 50, 30% of 40, and 0% of 50 for each of those balances after we redeem these conditions. And I mean to say that in token A. So our balance here was 950. It's now gone up to 997. Very cool.
Yeah, 47.
I got that total.
Yeah. So that checks out.
Cool. Alrighty, and then I guess redeeming a deeper position. Let's give that a try real quick. So we need to resolve this condition as well. And this one is I guess intended as a scalar condition, so we should resolve it as such. That. So we can report the payout here. The question ID for this one was 2. And so for our payout here, Alan, maybe you can tell us quickly what the kind of difference is here when you're reporting a scalar market. I mean, I think it's essentially the same, but if we're thinking about it as a scalar market, we have kind of a high and a low, right? And we
yeah, it is the same. Actually, you sort of already did it, because you already the first condition you resolved wasn't resolved like with all of the payout allocated to one outcome slot. So essentially, yeah, it's all about how you interpret the assets. So in the case of the scalar market, you would proportionally allocate more to the outcome token that the outcome is closer to. So if it's at the high end, then you would allocate 100% to the high. Conversely, if it's at the low end, it's 100% to the low. And then everything in between, it's like kind of a sliding scale between that. So like it might be 70-30, like already done.
Okay, cool. In that case, I'm going to say it's at or above high, just to make it feel binary, so we can do the opposite to what we did in the others.
Yeah.
So we'll report that payout, and then we'll redeem a position here that is, what do we do? B and high, so we need token B. Our parent collection ID should be the collection for condition. What?
It should be A because the collection is A and high, but the
Yeah.
token backing is B.
So we grab our collection ID there, our condition ID for condition 2, and our index sets are 1 and 2. And so I guess we can check our balance of here. We've got 900. And once we redeem our positions here, we should end up with oh, hold on. Just checking. B, A, and Y. I feel like I missed something.
Oh wait, what happened?
I'm not sure. So I redeemed this position here that should be collateral token B, parent condition A, condition ID is condition 2, and for index sets 1 and 2. So assuming that I would have had a balance of, maybe I just didn't have a balance of them. Let's double check.
Oh, you would have a balance of B in like the 45,305, the line 40 balance.
Yeah.
Is that what you're checking?
Oh, hold on. So I would have split. Right. That makes sense. Yeah. So, so when I redeemed, I didn't. It redeemed it for the underlying position, or like for the parent condition, not for the collateral.
Yes.
Yeah.
Because you're like you're at like depth 2. Then,
Right.
Yeah.
And so now I need to go and redeem for this one for collateral, right?
Yes.
So I go drop in my condition ID here. Sorry, no, that's not my condition ID. My condition ID would be this. Parent collection in this case would be 0. And index sets, I guess, in this case, I should still just do 1, 2, and 3 because it should cost less gas. Is that what you were saying?
Actually, in this case, you could probably, well, I mean, considering that this is the only position I think you have value in, right? Then it wouldn't matter. If it,
okay,
I can't remember if you have value in other positions in there. If so, then yeah, you should do 1, 2, and 4 or something like that. 3 is
oh yeah, not 3. Yeah. Cool. So let's go 1, 2, and 4 anyway. So there we go. And that should then give me the And that concludes our presentation. What happened to remix? Oh, wow. Luckily, we were right at the end here anyway, so I don't think it's hugely impactful. But well, yeah, and we got through kind of redeeming everything.
I hope that didn't actually break the blockchain. Like, if you try this and it will break mainnet or something, don't try this. Like, no, I don't actually think it will break mainnet. But like, yeah, what happened? Did you run out of RAM or something?
I don't know. Yeah, I don't see any. I can't see my console or anything. I can't imagine I ran out of RAM. I've got a whole bunch of it on this machine. But we should. I guess we can wrap it up there anyway. It's an eventful end to a fun walkthrough. So yeah, I guess we'll see how we go. Cool. We'll wrap it up there. Anyone who does watch it, thanks for tuning in. This was fun. The other video that's on the tutorials page is probably better, but this one was fun anyway. So,
this is fun. Should have similar content though, but if you do want help, like actual support during the hackathon, you can reach us via chat.gnosis.io, and there's a channel in the Ethereum hackers Discord too that the first link is for a Discord, and the second link is for, or like the second's a Discord channel. Do you have a link to invite? Because I actually can't find that channel.
Do you mean the hackers Discord?
Yeah.
I don't have one on, but I can send you one.
You mean, yeah, the Ethereum hackers one for the hackathon. It's this one.
Oh, I think I do have that one, but I remember hearing about a channel. Maybe it is this. Huh.
This is the.
Nevertheless, we may as well cut the recording and.
Okay.
And
Yeah. Anyway.